Right, welcome to part 2 of question 6 of the end of unit test for year 9 acids. You'd think I'd get better at saying that. I said it 8 times, but you know, whatever. Final 2 questions. You are asked to complete and balance the following formula equations for the acid-alkali reactions given. Okay, so here's our acid, here's our alkali. Okay, and you've got to work out what they make and then balance the equation. Well, you know that an acid plus an alkali makes a salt and water. So even if you hadn't got a clue about anything else, if you wrote in the chemical formula for water, you get yourself a mark, H2O. Then you've got to decide the formula of the salt that's going to be made. Well, you know the salt is going to be the positive ion of the alkali, which is calcium, Ca, and the negative part of the acid, which is sulfate, which is the SO4 here. And you can do that. Okay, but now you've got to decide whether that's the correct formula for calcium sulfate, which means you've got to balance the charges, the ion charges, haven't you? You've got to have a neutral product. You've got to have all the positiveness of the positive ion cancelled out by all the negativeness of the sulfate ion. So you could either have remembered that calcium is a 2+ ion, or you could have worked it out from this, because you know that OH minus, the hydroxide ion, is a single charged ion, OH minus. And you can see the formula here is CaOH twice. So calcium needed 2 OH hydroxide, OH minus ions to cancel it out. So if it needs 2 OH minus, it must be Ca2+. And likewise over here, you could either remember that sulfate is actually SO4 2-, or you could say, well, I know that H+ is H+, and I can see that this sulfate needs 2 of them to cancel out all its negativeness. So if it needs 2 H+ to cancel out its negativeness, its total negativity must be SO4 2-. So it must be SO4 2-. So the question then is, calcium sulfate, what's the correct formula going to be? How many calciums need how many sulfates to balance out the plus of the calcium and the negativeness of the sulfate? Well, Ca2+ plus SO4 2-, those balance out, don't they? So the formula is going to be calcium sulfate. So now we've written in the correct chemical formulae, we can have a go at balancing it. And we're just going to balance it in the same way that we always do. We draw our tally table, left, right, and ions. Okay, and we go ion by ion. Hydrogen, we've got 2 here, and we've got some here. The hydroxide, the OH group, can we count that as one big lump left and right? Well, it's on the left, OH, but it's not here on the right. So it does get split up, so no, we can't. So we're going to have to split it up ourselves. So 2 hydrogens, plus I've got a hydrogen there, but it's inside the bracket, so everything inside the bracket is times by the number outside the bracket. So it's 2 times 1, 2 hydrogens there, 2 hydrogens there. I've got a total of 4 hydrogens. The sulfate, can I count that as one big lump? It would be dead easy if I could. It's a sulfate there, and over here it's still a sulfate. So we're just going to treat it as one big lump. We'll call it SO4, which is what it is. I've got 1 SO4 over here, and 1 SO4 over here. Calcium, I've got 1 calcium here. The hydroxide ion is made of an O and an H atom joined together. We know it gets split up, so I've got OH in a bracket with a 2 after it, so everything in the bracket there's 2 of, so there's 1 O in the bracket, 1 times 2 is 2. That's my tally chart for the left hand side. Looking at the right hand side, how many calciums have I got? I've got 1. How many sulfates have I got? I've got 1. How many H's have I got? I've got 2. How many oxygens have I got? I got 1. So, looking at our balance, 4 and 2, not happy. 1 and 1, happy. 1 and 1, happy. 2 and 1, not happy. I need to somehow get 2 more hydrogens and 1 more oxygen on the right hand side. I can't change the chemical formula of anything I've got. All I can do is add more by putting a ratio number in. So let's try this. Let's put a big 2 in there. And as soon as I've put a ratio number in, I do a recount. So hydrogens, I've now got 2 lots of H2. 2 times 2 is 4. How many, let's do it in order. How many sulfates? I've still got 1. How many calciums? I've still got 1. Oxygens, 2 times 1 is 2. Let's look at the balance again. Now, hydrogens 4 and 4, oh, happy. Sulfates 1 and 1, happy. Calciums 1 and 1, happy. Oxygens 2 and 2, happy. OMG, we've balanced the equation. 3 whole marks. Final question. HNO3, which we're not scared of. We know that it's nitric acid, and even if we didn't remember, we can remember from a couple of questions earlier. There it is, HNO3, nitric acid, plus BaOH twice, BaOH2. Okay, well, Ba, do we know what Ba is? Well, we could look it up. Look, we could go over here, we could have a quick scan through the text. Oh, look, there it is, it's barium. Okay, barium. That's not really important. What we do know about it, OH, BaOH2, we know it's an alkali. Okay, and we know that this is an acid. First thing we've got to do is we've got to find out what 2 things are made in this reaction. Well, we know that an acid plus an alkali reaction makes a salt plus water. So the very first thing we can do for a free mark is we write in the chemical formula of water, H2O. Now we've got to find the name of the salt. We know the salt has the positive bit from the alkali, that's Ba, the barium, and the negative bit from the acid, the NO3. So it's going to be barium nitrate. But we've got to get the chemical formula of barium nitrate right. And that means balancing the charges. All the plus of the positive ion must be cancelled out by all the minus of the negative ion. But Mr. Ashton-Tyler, I can't remember, I don't know, I've never met barium, and how would I know what the charge on a barium ion is? But you do know, because it's BaOH2, and you know that OH, the hydroxide ion, is an OH single minus ion, and barium needs 2 of them to cancel out all its positivity. So 2 lots of 1 minus is 2 minus, so Ba must be Ba2 plus, hence BaOH2. But Mr. Ashton-Tyler, I don't know what a nitrate ion is. I can't remember what a nitrate ion is. You can't possibly expect me to remember what a nitrate ion is, but you don't need to know, because look over here, it's got HNO3. Okay, and you do know that it's an H plus. So an H plus ion only needs 1 NO3 ion to cancel out its positivity. So if it only needs 1 to cancel out 1 plus, you know it must be NO3 minus. Right? You know that. So H plus NO3, HNO3, HNO3, it must be an NO3 minus. Okay. So the question then is, Ba2 plus, how many nitrate ions will Ba2 plus need to cancel out all its positivity to make it neutral? Well, it's going to be 2, isn't it? It needs 2 nitrates to cancel it out. So going back over here to form the formula of barium nitrate, how am I going to write Ba and 2 lots of nitrate ions? Well, I could write it out like this, BaNO3, and I need 2 of them, so I'll put a 2 there. But that's no good, is it? Because that means 1 barium, 1 nitrate, and 32 oxygens, and that's not what I need. I need 1 barium and 2 nitrates. So how do I write that? Well, I've got to whack in the brackets, haven't I? I've got to do this. I've got to say 1 Ba, a nitrate 2 times. 2 lots of everything inside the bracket. So the correct formula for barium nitrate is BaNO3 2. That's for your second mark. The third mark is for the balance. And to do the balance, we're just going to do our tally chart again. We're going to do left, right, and ions. We've got hydrogen. How many hydrogens there? We've got 1. We know that we've got more here and that the hydroxide ion gets split up, so we can't count it as one big ion. So I've got 1 there, I've got 1 inside the bracket, but I've got 2 lots of everything inside the bracket, so it's 2 times 1, 1 plus 2. I've got 3 hydrogens in total on the left-hand side. The nitrate ion. Well, the nitrate ion is here as an NO3, and it's over here as an NO3, so I'm just going to count it as one big lump. How many nitrate ions have I got over here? I've got 1. 1 NO3. How many barium ions have I got on the left-hand side? I've just got the 1. And how many oxygen atoms have I got in total over here? Well, I've got 1 inside the bracket and 2 lots of everything inside the bracket, so oxygens, I've got 2. Now moving over to the right-hand side. How many hydrogens first? How many hydrogens in H2O? H2, just 2, isn't it? How many nitrate ions have I got? Well, I've got 1 here inside the bracket, but there's a 2 outside the bracket, so it's 2 lots of everything inside the bracket. I've got 2 nitrate ions. Bariums, how many have I got? I've got 1. How many oxygens have I got? In H2O is just the 1. Now we take a step back and look at the balance. Hydrogens, 3 turns into 2, that's no good. Nitrates, 1 turns into 2, that's no good. Barium, 1, 1, that's okay. Oxygens, 2 turns into 1, that's no good. First problem I'm going to solve is I've got to solve the case of the missing hydrogen. I've got to add more hydrogens in on the right hand side because 3 have turned to 2 and I've got to add in. I can't have that. I can't change the formula of water. The only thing I can do is add a big number. So I'm going to put a big ratio number in, and as soon as I have done, I'm going to do a recount. Hydrogens on the right hand side, I've now got 2 times 2. 2 times 2 is 4. Nitrates have stayed the same at 2. Barium stay the same at 1. Oxygens, I've now got 2 times 1. I've got 2. Let's look at our balance now. Have things got better? Well, 3 is now 4, so it's still not balanced. 1 is still 2, that's not balanced. 1 and 1 is good, and 2 and 2 for oxygens is good. So, I need to go again. I'm now short of hydrogens on the left-hand side because 3's turned into 4, can't have that, and nitrates 1 turns into 2. So how can I add more hydrogens and more nitrates on the left-hand side of the arrow? I can't change the formula of nitric acid, but what I can do is add a big ratio number. When I add the big number, I now immediately do a recount. How many hydrogens have I now got? Well, I've got 2 times 1 is 2 there, plus my 1 times 2 there. 2 plus 2 is 4. How many nitrates have I got? Well, I've got 2 times 1, I've got 2 nitrates. My barium stays the same, and my oxygen stays the same. Now let's look at the balance again. Hydrogens 4 and 4, happy days. Nitrates 2 and 2, happy days. Barium 1 and 1, happy days. Oxygen 2 and 2, we're all balanced and tickety-boo. And that's the end of the test.